let's try SNS2. So remember, the first thing we do every single time when we name anything, we say is it ionic, molecular, acid, right? Ionic, metal and non-metal, molecular, two non-metals. You gotta ask, we have to ask that question to ourselves every single time. So, okay, SNS2, okay, tin, where is it? Oh, it's under the stairs. It's ionic, right? Because it's a metal. And I wrote here everything you can have on your periodic table, right? This is what if you want to print your periodic table out for your quiz or your exam, here's everything you can have on it, right? The stairs, see how they're already on this one, so I didn't put them on there again. But if they're not on the one that you can print out, so feel free to put those stairs on. This is ionic because SN is under the stairs. Okay, so that means no dyes and tries. So this is going to be tin sulfide. Remember, "ide" because sulfur is from the periodic table. That's why the "ide" is here. It doesn't say "ide," it's probably a polyatomic ion. Okay, now, tin sulfide. Unfortunately, tin is under the stairs here, which means it has multiple charges, which means we have to put Roman numerals. Okay, so how do we figure this out? Well, we know sulfur's charge, right, is -2 because this whole group is -2. So sulfur's charge is -2, and we have 2 sulfurs, right? So we have 2 sulfurs. We know that the net charge for any ionic compound has to be 0. So sulfur is a -2, and there's 2 of them. So when we add this, that means this has to be +4. So it's tin 4 sulfide. Okay, next one. And again, anytime you have questions, just ask away. The next one, again, ionic, molecular, acid. So look here, Ag. Here's Ag. It's a metal, it's ionic. No dyes and tries, it's ionic. So it's silver and sulfide again. That's kind of nice. Now, the question is, does it need Roman numerals? Well, it is under the stairs, but it's part of the little magic triangle. So it doesn't need Roman numerals. So we're just done because it doesn't need Roman numerals. So we're good. We don't have to do anything else. The only ones that are extra work are the ones with Roman numerals. Questions on this at all?
I have a quick question. Would it be marked wrong if we put a Roman numeral?
Yes.
Okay.
Yeah. So this is what let's see here. Any of these that are in the shaded region here, all of these need Roman numerals. Any of them not shaded never need Roman numerals. And it's actually incorrect if you put Roman numerals. So like for this one, calcium and bromine. So again, we would look, is it a metal or a non-metal? I mean, if it's ionic or molecular. Well, it's a metal. So no dyes and tries. So it's calcium, bromide. And then we look, calcium is not part of the shaded area, right? It's not a transition metal. So we would not use a Roman numeral. So if we put a Roman numeral here, that would actually be considered incorrect. And on your quiz and your exam, I guarantee you those multiple choice questions all have some Roman numerals in the places where they don't belong. So the triangle, the questions, can you put the triangle on your periodic table? Absolutely. Yeah, so everything that I have right here written on this periodic table, you can have on your periodic table. Yeah, you can absolutely have all that. And again, this you can put on there too. It's just, I didn't draw it on this one because it's already in black, but I don't believe it's on the one I gave you. So make sure you put that little non-metal metal barrier there. All right, let's do the next one. Sr and N. So strontium, metal, ionic compound. Strontium nitride. tried. Again, IDE means it comes from the periodic table. That's what IDE means, straight from the periodic table. Like bromine becomes bromide, right? So when we do this, now the question is, do we need Roman numerals? Well, it's not a transition metal, so no, we do not. So we are done, right? The only ones that are really tricky are those Roman numeral ones, because we actually have to write them, but it's non-metal, we don't have to write them. So strontium nitride, and we're done. Okay, any more questions on this one, on these? Okay, we're gonna go to the next piece. Okay, this one is a little bit different. This one has a hydrate. We're going to be doing an entire lab with hydrates, but in your Chem 101, we talk about it, but I didn't talk about it in the lecture, so I want to make sure to talk about it now. A hydrate just means water. It's not a polyatomic ion. Like the word hydrate literally just means water. That's what hydrate means. Hydrate means water. Hexa means 6. So this just means 6 waters. That's what hexahydrate means, 6 waters. If it said dihydrate, that would be 2 waters. Okay, so let me show you how we do this piece. So magnesium nitrate. Okay, well magnesium, you already memorized that magnesium is Mg. You don't even need to look at your periodic table for magnesium anymore. Now nitrate, it does not have an IDE, right? It is not nitride. Nitride is here. Nitride is on your periodic table. Nitrate is a polyatomic ion. Again, gotta memorize our polyatomic ions. It's NO3 minus 1. Gotta memorize that. Magnesium is right here. This whole group is +2. So it's +2. Again, all ionic compounds equal 0. So if magnesium is a +2, we have one nitrate that's a -1. We need another nitrate. So we need 2 nitrates. So it's going to be Mg NO3 2. Again, we have to use these parentheses, otherwise it looks like you have 32 oxygens. We don't have 32 oxygens, we have 2 nitrates, right? So that's our magnesium nitrate, and then we have to put the rest of it in here. So it's going to be Mg NO3 2, and then here's how we say the hydrate's attached, 6 waters, right? So this, let me erase my hot mess of this stuff. This, bye. My mom's leaving. Okay, so here's our hexahydrate. So this right here is this. These are the same thing, 6 waters. So, and then again, this is our magnesium nitrate, right? You can just leave them out, it's fine. Okay, so this is our answer. So hexahydrate, it just means add 6 waters to whatever you're doing. And that's our hexahydrate. Okay, any questions on this one? I'm good with this? Okay, so for the polyatomic ions, you definitely need to know the ones in bold, and you have to be able to use the little sliding scale. I'm not going to use any other polyatomic ions that aren't in bold or on that sliding scale, except for possibly chromate, because we use chromate all the time. But I can go back to, so all of these in bold, you definitely need to know. So like, you definitely don't need to know peroxide, we don't use thiocyanate, oxalate. These we do use often. We don't use these, we don't use these, we don't use these, don't use that one, don't use that one, don't use that one. We really don't use that one, don't use that one very often. But the rest of these are all you can use on a sliding scale. So here you really, again, and I'm going to go over the sliding scale in just a minute. So you just really need to know chlorate, nitrate, phosphate. That's really all you need to know. And sulfate, carbonate, right? Because anything with the H, those are the sliding scale I was talking about. So again, all of them that I don't have circled, you don't need to memorize them because once you know how to use the sliding scale, you don't need to memorize them. And I'll show you what that sliding scale is. It's in the third lecture, which everybody's seen by now, but some people asked me to go over it again, so I definitely will. Okay, so let's try these. Okay, so tin 4 sulfate. So this is just going the other way. So tin 4 just means, so here's, I'm just gonna put it down here. Here's tin. This means +4. It doesn't mean there's 4 tins. It means the charge of tin is +4. Sulfite, I don't know what sulfite is, but I memorized sulfate. Ite means it lost 1 oxygen. So sulfite is SO3, 2 minus. SO3, 2 minus. Okay. So now when we do this, again, it needs to equal 0. When we add these together, this is +4, -2, so I need 2 of these. So it would be SnSO3, 2 of them, right? So another way to think of this right here is 1 tin is a +4, 1 sulfate is a -2, so we need another sulfate. So when we add this up, +4 -2 -2 is a 0. This extra sulfite here, there's 1, 2 sulfites, that's where that 2 comes from, right? That's what the charges are. That's why we have the 2 with the charges. That's just another way to think about it. Okay, copper 2 nitrate, or copper 3 nitrate. So again, this 3 means copper, its charge is +3. So it's Cu +3. Nitrate, doesn't say "ide," polyatomic ion. NO3 minus. Again, it has to equal 0. So we have 1 copper, that's a 3+, and 1 nitrate. Well, we need 3 nitrates because we need it to be -3. So we need 3 nitrates. Oops. So it would be CuNO3. And again, we need 3 -1s. So we'd have a 3 there. Okay, let's try the next one. Now, cobalt and Cn. So now we're going the other way. Again, here's our cobalt. It's in the middle, ionic compound. Cobalt, polyatomic ion. Remember, if you see a metal, this is a metal, and there's more than 1 atom after the metal, looking at a polyatomic ion. This is cyanide. Well, this is also a transition metal, which means perhaps use Roman numerals because it has multiple charges. So how do we do that? Well, cyanide is a -1, and there's 3 of them. That's supposed to be a 3. So this side is a -3, so this has to be a +3. 1, 2, 3. Okay, so there's a few others. So any questions about these so far?
I have a question on the previous one that you did, the last one.
Uh-huh.
So I saw that you didn't raise up the 3, right? The one from the parentheses. And the one before you did, is that because it has a parentheses? You take the 3, the bottom 3, and multiply it?
You mean this one?
Yeah, so the 3 at the end, the charge.
Yeah, so this, I'm just going to write this a different way. So what this is saying is it's saying we have 1 cobalt and we have 3 CN, 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 CN. We have 3 of them. Each of them has a charge of -1. So therefore, if each of them have a charge of -1 and there are 3 of them, that's where this 3 comes, because there's 3 CNs. That's where the 3 comes from.
Okay.
That's why this has to be a +3. Does that help you understand where this 3?
Yeah, because I noticed, okay, because I noticed, I think on another one you did or you didn't, I don't know, yeah, I just got confused, but thank you.
Okay, yeah, so where this comes from, this is just using, it's using the number of ions that we have, the number of polyatomic ions. So this 3 means that we have 3 atoms or 3 polyatomic ions. Each of them, so there's 3 of them, each of them has a -1 charge. And I'll go over some more of those. Somebody just had another question to go through. I'm going to put them in right now. Okay, any more questions while I type these in? Any other questions? I'm just typing some more in here.
I have a question for the molecular ones. If the first element has a prefix, how would be the ending of that word? Would it end with IDE?
No, you would just say that you just say whatever it is. So like if it was like P2, you would say diphosphorus. I know it seems a little weird, but you would just like, or if it said like, oops, N2, that would just be dinitrogen.
Okay, thank you.
You're welcome. Okay. Sorry, I'm trying to type these in here so I don't have to write them. 4, 4, 8. Okay, so let's do chromium. Where's my mouse? It's not working. Right, my mouse literally just stopped working. Sorry. Let me try this again. Hold on 1 second. Now, my computer stopped working. This is what happens when I try to do anything with Zoom. Hold on 1 second. I'm going to try to stop sharing and see if I can fix this. Nope, not yet. I'm going to save it before my computer crashes. Okay, I got it back. I think I fixed it. I fixed it. Okay, so sorry. My computer, whenever I do anything but PowerPoint and I try to do anything, it crashes. Okay, so let's try chromium 3 carbonate. So this 3, again, means that this charge of chromium is a +3. So we have one chromium, its charge is +3. Carbonate is a polyatomic ion. We have to memorize that one. It's CO3, 2-. So this whole carbonate's charge is -2. So we have one chromium and we have one carbonate. We need their charges to equal 0. So in order to do that, I'm going to try it like this, see if this helps. So right now we have one chromium and one carbonate. So we need one chromium. Let me just do +3 to stay consistent with the way I'm writing these. +3, +3. So we need 2 chromiums because these will be +6. Plus CO3, 2-, plus CO3, 2-, plus CO3, 2-, because these will be our -6. When we add all this together, we get a 0. So therefore, we need 2 chromiums and we need 3 CO3s. Okay, does that help a little bit with the way I broke it down like this? So this right here is this, right? So that's what we're doing with our charges. We're trying to figure out how many ions we need to make it be a 0 in the end. Okay, let's do.
Professor,
Go ahead.
I wrote that on the lab, the one that was due last night, and I don't know why I got it wrong. Because I wrote the same thing that you wrote, and it marked me wrong.
Maybe you had a space, or this was a 0 instead of an O.
Oh, okay then. Mm-hmm.
That would be send me a picture of it and I'll because it's like the smallest thing sometimes. Send me a picture of it and I'll see if I can figure it out. Okay. Let's try this one, Na3PO4. So that's sodium, which is a metal. So this is an ionic compound. And then PO4, remember, when you see a metal and there's more than one atom after it, it's a polyatomic ion. So whenever you see a metal and there's more than one atom after it, polyatomic ion, this is phosphate. Now, the question is, does it need a Roman numeral? Because it's an ionic compound. It's sodium. It does not need a Roman numeral. So you're done. Sodium phosphate. All done. Don't need to worry about anything else. It's wonderful when they don't need Roman numerals. Okay, let's try this one. Here's sodium again. Oh, that's not on the periodic table. That does not say "ide." This is a polyatomic ion. Which polyatomic ion is it? Chlorite. Sounds like chlorate to me. I know that chlorate is ClO3-. I've memorized my little sliding scale. Hypoite means I've lost 2 oxygens. So this must be ClO-. This is a +1. This is a -1. So this is just ClO. I don't need to do anything with the ions because hypochlorite is a -1. Sodium is a +1, right? Because they're all +1s here. So just the answer is just NaClO. Okay, another question. We'll just do this one really quick. NO. NO. All right. Question is, where's N? Oh, it's over here. And O is over here. Not an ionic compound. Not an ionic compound. This means we actually do use dis and tris. This is a molecular compound. Now remember, we don't use mono for the first one. So this would just be nitrogen. But we do use mono for the second one. So nitrogen monoxide. Okay, now to expand on the question someone just had, I'm going to do it over here. What if we had N4O? It doesn't exist, but let's pretend it does. This is a tetra. So it would just be tetra, nitrogen. And again, there's only one O, oxide. Again, it's because there's two nonmetals, and that's when we use our dyes and tries. Yay, we get to use dyes and tries. Okay, let's go to the next page. So the question was this one, SNSO, oh, sorry, I'm just gonna write the whole thing out. Tin sulfate, tin 4-sulfate, sulfite. Let me just do this one. Maybe I didn't. Oh, I did tin sulfide. Okay, tin 4-sulfate. Okay, so tin again is SN. SN is +4. It's a metal, right? Sulfite is like sulfate, but lost an O. I have no idea what just happened to my screen. Okay, got it. So it lost an O. So sulfate is SO4 2-. Ite means subtract one oxygen. It's SO3 2-. So this is SO3 2-. That's its charge. Okay, so when we do this, again, they need to equal 0. So right now we have 1 tin 4 and 1 SO3. Well, we need another SO3. All right, my computer. I'm just gonna like close everything in my computer right now to see if I can maybe get this to work better. Just gonna close everything. It's like not responding at all. I can't shrink my screen back. There we go, got it. Okay, so we have +4, and again, we need this to be 0. Every time I touch my screen, it just gets bigger. All right, there, now I can write on again without it getting bigger. So again, this is +4, and this is a -2, so we need 2 sulfites. So SN, SO3, 2. So doing this another way, right now we have 1 SN, its charge is +4. And we have 1 SO3, its charge is -2. We need it to equal 0, so we need to add another SO3. So now when we have this means 2 SO3s because we need them to equal 0. Okay, does that help with the tin sulfite question? Okay, if you're doing the crisscross, it needs to be in the simplest form, by the way. So my guess is if you got this as your answer, if you got SN2, SO3, 4, because you did the crisscross, which that's my guess, these always need to be the simplest ratio. So that, what do I mean by the simplest ratio? If you divide this one by 2, you can divide this one by 2, and you get SN, SO3, 2. So if you're doing the crisscross, always the simplest ratio, right? Now, how do we know sulfite versus sulfide? Well, it'll tell you. So sulfite is SO3, sulfide is S2-. So you really have to look at the words really careful. These last 3 letters are going to be very important, right? If they don't say IDE, that means it's a periodic table. It's a polyatomic ion. If it says IDE, it comes from the periodic table. So anything that says, I can't erase that. Anything that says IDE at the end, that means it comes from the periodic table. If it doesn't end in IDE, it's a polyatomic ion. Okay. So now I'm going to go through acid naming. Some people have been asking about acid naming. So when you're naming acids, you have to know that sliding scale, right? Now, what's the sliding scale? So I went over it in the lecture and a lot of you have gotten pretty good with it, but I'm just gonna do it, I'll use, I don't know, at eighths, right? So you gotta know carbonate, sulfate, phosphate, I don't know, what other ones? Oh, chlorate. You gotta know the eighths, all the eighths. The eighths are all different. You never know with your eighths which one. They have different numbers of O's, they have different charges. You just have to know your eighths, right? So the ones that end in A, T, E, those we're just gonna call regular. Those are just regular. If you lose one oxygen, they become ite. If you lose two oxygens, they become hypoite. Hypoite. If you gain one oxygen, they become per 8. So let's just use, I don't know, let's use sulfate. So sulfate is SO4 2 minus. If we lose an oxygen, it becomes sulfite, SO3 2 minus. If we lose two oxygens, it becomes hyposulfate. If we gain an oxygen, it becomes persulfite. Persulfate. I want you to notice that the charges never change. The only thing that's changing is the number of oxygens, right? And that's why if you remember what the regulars are, you don't need to know all the other polyatomic ions because you just go up and down. And you have to learn the scale anyway because you have to use it to name acids. So you might as well name it. So when I said, I'll come right back to the slide. When I said back here, you don't have to memorize all these because we're just going up and down the sliding scale with most of these, right? So you don't need to memorize them because we're just using the sliding scale, right? So like perchlorate, right? If chlorate is, I can't erase this. If chlorate is the regular, chlorite lost one oxygen. So you had 3 oxygens, now it has 2. Hypo lost 2 oxygen. These are O's. Per gained an oxygen. So all you need to know is chlorate. And when you're doing this, these 3 are all exactly the same. So chlorate is ClO3 minus. That's the only one you need to know. Iodate is IO3 minus. Bromate is BRO3 minus. They have the same number of oxygens and the exact same charge. So all you need to know is this one. Just remember chlorate. So if I go up here, see, if you know chlorate, then you know bromates, you know all the bromates, and you know all the iodates. You know them all. So you don't have to worry about those. You just need to know. So if you know chlorate and you know this sliding scale, on this side of the polyatomic ions, all you need to remember is chlorate, nitrate, phosphate. All the rest of these polyatomic ions are using the sliding scale, which you have to learn anyway for acid naming. So it makes our life a lot easier. So it cuts down the number of polyatomic ions like less than half that you actually need to remember. You just have to know how to use this scale right here. And you have to learn the scale anyway. So this is, so let's see here. This is going to be the polyatomic ion. Polyatomic ion. This is the number of OX oxygens. Okay. So now I'm going to do it with how you do it with the acid naming. So here's the acids. Okay, so in an acid, the 8s all become ics. So this becomes per ic acid. This just becomes, here we go again. Every time I touch it. Let me try going, I have no idea what's going on with my computer right now. Every time I touch my screen, it just gets bigger. Hold on, let me just try something really quick. All right, there we go, fixed it. So 8s just become ics, so it's just gonna be ic acid. Ites become us's, so this is just gonna be us acid. Hypoite, again, ites become us's, this is just gonna be hypo us acid. Sorry, I'm trying to write neatly, it's not working so well. Okay, so let's do it with our sulfate again. Actually, no, let's use, I can't erase that. Let's use phosphate this time. So if we do this with phosphate, so the regular phosphate is PO4 3-. So as an acid, phosphate is going to become phosphoric. Now, how do you know how many H's? It's the same number of H's as the charge. So if the charge is -3, that means we need 3 H's. So it's going to be H3PO4, and it will be phosphoric acid. So let's do phosphite. Again, phosphate is PO4 3-. Phosphite loses 1 oxygen. So it is PO3 3-. Remember, the charge never changes, just the number of oxygens change. So this is going to be phos for us acid. Again, number of H's, same as the charge. H3PO3. Right? And so this is that sliding scale I keep talking about. You have to know how to use it. It makes your life so much easier. You just have to remember, 8 is regular. Memorize anything that ends in ATE. You just have to know those. Ite means lost an oxygen. Hypoite, lost 2 oxygens. Per 8, gained an oxygen. When we have acids, 8s always become ics, 8s become ics, ites become us's, ites become us's. Oops, us's. Okay, I'm going to clean this up for you. So let's use this right here, trying to make it clean for these. So let's try H2SO3. Okay, SO3 looks a lot like sulfate. Okay, I memorized sulfate because it's my regular. Sulfate is SO4 2-. This has 3 oxygens. Sulfate has 4. I have lost an oxygen. This is sulfite. This polyatomic is sulfite. Ites become us's. So this is sul here us acid. Okay, now our next one, this is a polyatomic ion, it's acetate. You just got to remember that that one's acetate. 8 becomes X. This is an acid, so this is just acetic acid. It's just acetic acid. It's a little hard for this one. Here's our 8. It just becomes an ick. This one is just a polyatomic ion. When you see a really long polyatomic ion, it's acetate. It's a big, long polyatomic ion. Okay, how are we feeling on acid naming? Better? Does anybody want to do any more acid naming? Questions on acids? Good on acids? Yes. Okay. And again, this sliding scale, you have to commit it to memory. I always tell people to just write it down a few times, but if you practice it, like when you're doing, like you're finishing your Chem 101, just going through the sliding scale with these polyatomic ions makes your life so much easier. Again, if you're like, I don't want to do this, okay, that's fine. You don't have to. You just have to memorize all of these. Which I can't erase these. You just have to know these then. So your choice is either learn 3 or learn 20. I mean, it's, again, if some people don't like the sliding scale, that's totally fine. If you're like, I like flashcards, I'm just gonna memorize the polyatomic ions, you can absolutely do that. That'll work the exact same way. You just have to memorize more of it, but you could do it that way. Not a problem at all. Okay, so again, this is our little acid naming helper and our polyatomic ion learner. Okay, so, oh, great question. How do you know the number of H's in an acid? Remember, the H's are the same as the charge, right? Because hydrogens are +1. So for example, if you had, I don't know, let's do, I'm just gonna make one up, a hard one for you. Let's do hypo phosphorus, excuse me, acid. Okay, hypophosphorus acid. Okay, so phosphorus, you're like, I don't know what that is. I know phosphate. I memorized phosphate. Phosphate is PO4 3-. Hypo means lost 2. Okay, so that means we lost 2 oxygen. So phosphate is PO4 3-. Hypo means I lost 2, PO2 3-. Remember, charges never change, right? So -3, -3, never changes. Okay. Now, the number of hydrogens is the same as the ion's charge. So since this is -3, we need 3 hydrogens. So it would be H3PO2 because hydrogen is +1. So we need 3 +1s to even this charge out. And so it's H3PO2. Now, another thing people were asking about, so acids always have AQs after them. We're going to talk about in the lectures this week, the rest of this week and next week, this AQ thing and why it's so important. AQ just means dissolved in water. So right now we're really just learning the naming of them. So if you're like, what? It's okay if you don't put AQ right now because this whole, the chemical reactions lectures that you're watching this week and the early next week, we go into AQ into great detail and why we use it and why it's so important. But all acids, like the definition of acid is that it is in water. AQ just literally means in water. So technically all acids are in water. So we technically should be putting AQ after each acid. But it's okay if we don't for this exam and this quiz, that's okay. You'll see the AQs there, but I'm not going to count it wrong if you forget to put an AQ. On exam 2, I will, but not on exam 1. Okay, so let's do another acid. Let's do HF. So do you see how this uses the number of oxygens, right? There are no oxygens. So if no, just gonna put this, sorry. If no O, use hydroic acid. See, there's no O here. So this would be hydrofluoric acid, right? So this is just a little, if there's no O's, use hydro. Okay. And F is a -1, so we have 1 H, because H is a +1, 1 H. Okay, so now the last question were some of these. Now I put all of these questions in a completely miscellaneous order. So some are ionic, some are acids, and some are molecular. So when you're taking your quiz and your exam, this is what I suggest you do. You look at the problem and then you look at your periodic table. So for example, CaSe, metal, ionic, right? Write the I on there. So you're like, okay, ionic means no dyes and tries, right? Starts with an H. Oh, acid. K. Metal. Ionic. Right? I suggest that you do this just to put in your brain, to, like I always tell people, your brains can only do so much, your hands have to do some work too. Write what it is so you remember how to name it. Okay, so let's do the first one. Calcium and Se. Definitely ionic. So calcium, selenium. I could have, this one's a little hard. Selen, IDE, because it's from the periodic table. Calcium does not need Roman numerals. Again, I'm going to put the ones that need Roman numerals, I'm going to shade them so you can see. So all of these need Roman numerals, nothing else does. So I'm done. It's just calcium selenide, I don't have to do anything else. H3PO4, acid. I know that phosphate is PO4 3 minus, right? Phosphate's PO4 3 minus, there we are. So phosphate becomes an ick, because 8's become ick. So this is phos or ick acid. Okay, next one. K, metal, ionic, no dyes and tries. More than one atom, polyatomic ion. So this is potassium. And this is SO4. Okay, SO4. SOs, I know that's sulfate. So in my brain, I memorize sulfate. SO4 2 minus, have to memorize those 8s. So this is sulfate. Again, potassium, not a transition metal. I don't need to do anything else. I just name it. All right, VS2, what a weird one. V, S, ionic. What's a V? Oh, it's vanadium. Vanadium? I think I spelled that right. The periodic table you get to print out and the periodic table that's on your quiz has the element names on them. So I have to memorize them because I'm not looking at this, but you can just look at the periodic table. So vanadium, sulfur, straight from the periodic table, so it's sulfide. So did you see how this one right here, polyatomic ion, sulfate, S, periodic table, IDE, right? IDE means from the periodic table. Now vanadium's in the middle. Roman numerals, okay. Sulfur is in this group, so it's -2. Just gonna do it where I have some more room. There's 2 of them. There's 2 sulfurs, right? So we have V and an S and an S. This is -2, this one's -2. So together, these are a -4. So that means this must be a +4. So this must be a +4 in order for all these to add up to 0. So this means vanadium 4 sulfide. Okay, next one. Magnesium. Metal, ionic, no dyes and tries. Magnesium chloride. Magnesium's not in the middle. No Roman numerals needed. Easy peasy on the naming. Okay, next one. S. Oh, and Cl. 2 nonmetals. This is molecular. I use dis and tris because it is molecular. So do you see how the first thing we have to do is decide what rules of naming are we using? Are we using the ionic rules? Are we using the molecular rules? Or are we using the acid rules, right? So there's 3 distinct things in our brain. So we need to decide which one are we going to be using. This is molecular. There's 2 sulfur, so disulfur. Remember, the first one, you just write the name. Whatever the name says on the periodic table, you just write it. Tetra. And the second one, you just add IDE to it. Chloride. That's it for molecular. All right, next one. Oh, starts with an H, it's acid. And there's no O's. If no O's, hydroic acid. So this is hydro, bromic acid.